You're welcome again, and thanks for the privilege as we continue with our mathematical series. Here in this class, we're going to learn polynomials and polynomial factorization. Polynomials and polynomial factorization. Now, before I go into that properly, let me also remind ourselves with the concept of algebraic expressions. Algebraic expressions. Now, what are algebraic expressions? I know we, in solving mathematics, we are used to coming across expressions that are a combination of both alphabets and numbers, like say A and 2, A plus 2, where this A here is unknown and this 2 is a known number. Is a numerical number. Now, this kind of expression where we have a combination of alphabet and number is referred to as algebraic expression. An expression where we have a combination that consists of an alphabet and a number is referred to as algebraic expressions. Now, examples of some of these are A minus 3, you can click A minus 3, 5 itself, which is a constant. In this case, we assume that the A, which is the unknown, is 0. We also have the case, we can also consider that of just A. In this case, we assume that the constant is also 0. And we have, in the first case, we have this plus 2, and then we can also have also 5, a constant multiplying the unknown, multiplying the unknown, and if you simplify this, this is straight away just 4a, this kind of expression. We can also have that of 6a dividing a, and this we have to be just 6, or if you say yes, just a 6, or you can also consider things like 8a divided by 8, where you have the constant a. Now, all these that we have written here, first of all, is just a constant. A constant is also an algebraic expression. Now, it is, though in the definition we have said it's an expression that consists of an alphabet and a number. But in this case, where you have it, this is also an algebraic expression because we assume that the unknown, which is the alphabet, is 0 in this case. Now, in this case, this is also an algebraic expression. Now, in this case, we assume that the constant is 0. So we just have only the alphabet. Now, here in this case, we have both the alphabet and a number and an operator in between them. And with the operator here is the addition operator. This one is also, this expression is also an algebraic expression. These are also algebraic expressions. Now, in this case, where we have these unknowns, now these unknowns sometimes, and in some cases, we can refer them to as being a constant. Now, it becomes a constant, like in this case, if we have an expression, say A equals 0. Now, A is a constant. A is a constant. It's a constant because it assumes just one number. A must take only one number, such that when you add it to these two, the resulting figure will be 0. A is a constant. In this case, it's a constant because it must take only just one value, such that when you add that value to this, it becomes a 0. So we are saying that these alphabets that we are considering, in some cases they can be constants. They will be constant in the case where if the unknown assume just a number, a single number. Like in this case, this one, if you want to determine the value of A, you just have A, taking this one to the other side, this thing becomes negative, and that is true. When you impute negative 2 here, negative 2 plus positive 2 gives you 0. So you can see that in this case, this A here, this variable alphabet here, is serving as a constant. Right? Whereas in some cases, if it assumes many numbers, it's no longer called constant again. It becomes a variable. Like example, if we want to talk about say 2, let's consider 2 plus 3. This we have to be 5, and you know that this is also equal to 3 plus 2. This is the commutative law of addition. Is commutative. This one, irrespective of what you bring first, is the same thing. So if we want to generalize this in mathematics, we can say, let's consider, say, y and x. Y and x is the same, plus x is the same to x plus y. Like in this case here now, this is not a constant. It is a variable, because we are saying that irrespective of the number you take, it doesn't matter the one that comes first, that the resulting answer will be the same. So this one must not only take 2, it can take 3, it can take 4, it can take any number, any integer number. It can take any integer number that is such that anyhow you put it, the resulting answer is the same. In this case, it assumes just a single answer, whereas in this case, we are referring to any number. So in this case, these are also alphabets, but in this case, they are not constants, but rather they are variables because they assume many numbers. So algebraic expressions are expressions that consist of both alphabets and numbers. Algebraic expressions are expressions that consist of both alphabets and numbers. Now, sometimes these ones, we can also have a case where we have multiple alphabets, such as, say, A plus B. A plus B. This is also an algebraic expression. We can also have A minus B. This is also an algebraic expression. We can also have A divided by B, and we say A raised to power B. All these are algebraic expressions, where this one, the power of this one, can also be greater than 1. In all these that we have considered, the powers are just 1, but I am saying that the power of the alphabet can also be greater than 1. So all these that we have presented here are examples of algebraic expression. But for the sake of this class, our interest is to talk about polynomials. Now, what are polynomials? Now, we are proud to tell us that polynomials are algebraic expressions. Now, being that algebraic expression is there now, we know that it must be a combination of both alphabets, or you say variables, and numbers. Now, we say polynomials, these are algebraic expressions that consist of variables, numerical numbers, and exponents. Variables, numbers, and exponents, but not division, division by a variable. Polynomial expressions are expressions that consist of variables, numbers, exponents, but not divided by a variable. Now, polynomials, we have said, these are expressions that consist of variables. They are algebraic expressions. Sorry, I said they are algebraic expressions that consists of the algebraic expressions or the algebraic expressions that consist of variables, numbers, exponents, and but not division by a variable. Now, example of such, or let's say in a similar way, we can say a polynomial in a particular variable, say y. A polynomial in a particular variable, say y, is an expression that involves powers of y, mainly in ascending or descending form. Let me write it. Let me also write this out. We can say in a similar way, we say a polynomial in, say, y, in a particular variable, is an expression. It's an expression that involves. It's an expression that involves powers of y, mainly arranged in ascending or descending form, in ascending or descending powers. Let me say powers. These are polynomials. You can say in a similar way, it's polynomial in y, such that they involve powers of y, mainly in ascending or descending form. Now let's consider some examples of such. If we say 5y, this is also a polynomial. It's a polynomial because you can see that it has a power of 1. Let's consider another one, say 3y plus 2. 3y plus 2 is also a polynomial. Now, this kind of polynomial where the power of the variable is 1 is also called linear expressions. They can also be called linear expressions. Linear expressions. Now, sometimes a polynomial can also be this. Now, if it's just a constant, we assume that the power of the variable is 0. The power of the variable is 0. The power of the variable is 0. So in that case, the degree of that polynomial is degree 0. This is a polynomial of degree 0. Now, what do we mean by this degree? Degree is the highest power, of the polynomial. The highest power of the polynomial is what we refer to as 0. Now, in this case, you will know that anything raised to power 0 is 1. So, in this case, we assume that the power of y here is 0, and that will be the highest power. That's why we just have the constant here. Whereas in this second case, the power of this one is of degree 1, and sometimes we call it linear expression. And let's also consider another one, say 2y raised to power 2 minus 2x plus 3. This one, if you look at it, what is the highest power of the, what is the highest power? The highest power here is 2, here is 1, here is 0. So you can ask, and we have said there are things that are arranged in either ascending from this definition. A particular polynomial in a particular variable, say y, is an expression that involves powers in y, mainly in ascending or descending power. So you can see that this is in descending power, where the highest power here is 2, here is 1, here is 0, and anything raised by 0 is 1. That's why that one is off the job market. And this kind of polynomial, we say, is the degree of it is named after the highest power. So degree here is of degree 2. This is of degree 2. And this kind of expression, sometimes we call them quadratic expressions. Sometimes we call them quadratic expressions. Now we can also have, these can also be called quadratic expressions. quadratic expressions. Now let's also consider other ones. Now, this kind of expression, as we have also said, you can see that the powers of the polynomials are also in the descending form, and then the highest power here is 3. So we say this polynomial is of degree 3, and sometimes we call it cubic expression. Sometimes we call it cubic expression. And in like manner, we can also have a polynomial up to power n, where n is any natural number, ranging from any whole number, where n is any whole number. Well, in that case, if it is up to 4, we say it's a quartic expression. Sometimes we call it quartic expression. While if n is 4 here, you will say the degree of that polynomial is of degree 2. Now, in a polynomial expression, we can also have multiple variables. Like all these that we have are polynomials of a single variable. They are all polynomials of a single variable. We can also have polynomials of multiple variables. We can also have polynomials of multiple variables, as like example 3x plus y raised to the power 4 plus y raised to the power 3 plus x raised to the power 2 plus y plus 2. This kind of expression is also a polynomial, where the degree of this polynomial is of degree 4. That's the highest power of that we have in the expression. This is a quartic expression of degree 4. But the variable is not a single variable. We have 2 variables. It's a polynomial that has 2 variables. So we are saying that a polynomial can also have more than one variable. It can have 4, it can have 5, as the case may be. So all these are polynomials. But there are some distinct things that I really also wish to bring to our notice. For a polynomial, let's consider some examples so that we really distinguish what those examples are, if they are polynomials or not. Let's consider some of the expressions to better illustrate what we are doing. Let's consider this. Let's consider, say, 8y. 8y. Is 8y a polynomial? Yes, it's a polynomial. This is a polynomial of degree 1. It's a polynomial of degree 1, and sometimes, as we said, it can also be called a linear expression. It can also be called a linear expression. Let's consider another example. Let's consider also another example. This minus this. Is this also a polynomial? That is also a polynomial. That is also a polynomial. Let's also consider another one. Let's say 2y x raised to negative 3. Now, is this a polynomial? Now, this one here is not a polynomial. Yes, some people might say, yes, it has the variables and the 2 variables. And from the expression, we said 2 variables are also polynomial, like this one. But this is not a polynomial because of this negative power. Polynomials, because this expression that we are seeing can also be written as 2 raised to the power this all over x raised to the power 3. This expression and these things are the same. And we have said from the division that a polynomial is not divisible, it's not divided by a variable. That we don't divide it by a variable. So you can see that this is being divided by a variable. So this one here is not, this expression here is not a polynomial. That expression there is not a polynomial because it has negative power, which will result in having a division. Division of a variable. Now let's consider also this over y minus 3. Is this a polynomial? That is not also a polynomial. That is not also a polynomial. Let's consider another one. 3y plus 1 over 2 times x. Is this a polynomial? Yes, this one is a polynomial because the degree of this one is 1 here. This is a coefficient. This one half here is also a coefficient times the x. In other words, you can also rewrite this one as 3y plus x all over 2. So it's the same thing. So it's not divisible by a variable. So this one is also a polynomial. That is also a polynomial. Let's consider another one. X raised to the power 1 over 3. Is this a polynomial? That is not a polynomial. That's not. Now, because from these ones that we saw, we have said that this n here takes only natural numbers. This n here takes only whole numbers, where it ranges from 0, n takes number from 0, 1, 2, on we go. But you can see that this is a fraction. So with the order of this one, when you're talking about the order of a polynomial, we name them in terms of natural. We name them in terms of natural or whole number, so that 0 can also be included. The degree of a polynomial, not in terms of fraction. So this one is not a polynomial, but this is a polynomial. This is only a polynomial, but because we have a fraction on top, we say it's not a polynomial. Now let's consider this 2 over x. It's 2 over x. We have said it's not divisible. You cannot divide it by a variable. So that is not also a polynomial. That is not also a polynomial. If you consider some cases, they are looking like this one. Anything that looks like this one, where the power of the variables are whole numbers, then you say those are polynomials. Then you say those are polynomials. Then in let's consider some cases, some special cases where in some textbooks they are used to describing polynomials. Now, a polynomial that has just one term, like this one and this, are called monomial. A polynomial that has one term, there are some special names that sometimes they use. A polynomial with a term is called monomial. A polynomial with a term, just one term, is called a monomial. Now, a polynomial with two terms is called binomial. When it is two polynomials with two terms is called binomial. Now, a polynomial with three terms is called trinomial, and so on. So sometimes when you are going through some of these textbooks, you might come across this monomial, binomial, and so on. So in other words, we have said that a polynomial is an algebraic expression that involves or consists of a variable, a number, and the power. But that expression must not be divided by a variable. Like these expressions that we have, they are not divided by any variable. And we have said for it to be a polynomial, it must not have a fraction as a power. It must not also have a fraction as a power. So with all these, at least we are used to what polynomials are. But before I conclude, let's just quickly see how we can evaluate some polynomials. Now let's consider one or two. Given that f of x, meaning is a function of x, let's say x raised to the power 3 plus 2x plus 1. Now we can say let's find f of 2. Find f of 2. Now, if you are asked to find f of 2, then you are saying you should evaluate it at the point when x is equal to 2. Evaluate this expression at the point when x is equal to 2. Therefore, this is f of x. Therefore, we say f of 2 evaluating at when x is equal to 2, meaning we have 2 raised to the power 3 plus 2 raised to the power 2 plus 1. There are some expressions like this where you just resolve everything to a single number. If you resolve this, 2 times 2 times 2 will give you 8, plus 2 times 2 will give you 4, plus 1. This plus this will give you 12, plus this will give you 13. And the answer will be this. So you can see that this polynomial expression that we have here, after evaluating at a particular point when x is equal to 2, we have succeeded in resolving it to just a single number. Let's also consider another one. If we can do that, just say f of y, if the meaning is a function, the word we want to write is a function of y, is equal to y raised to the power 2 plus 4y minus 8, that we should find this, evaluate it at x equal to 2, at x equal to 2. Now, if you are given this, yes, with this, if you have to simplify this or evaluate it, it's just pretty simple. Here is f of y, meaning it's a function, the expression is a function of y, it's expressed in terms of y, and we have been asked to evaluate it at when y is equal to 2. So whenever you see y, you put 2. Therefore, you say f of 2, therefore, will be 3 into 2 raised to the power 2, that's what we have, because the expression here is a quadratic expression, plus 4 into, this is y, sorry, y, so it's a 4 into 2 minus 8, that's what we have. So if you simplify this, 2 times 2 will give you 4 into 3 plus 4 to this will give you 8 minus 8. You can see that this side is already off the job market. Positive 8, negative 8 is off, and we will be left with 3 times 4, which is equal to 12, which is equal to 12. So in this expression, if you evaluate it at 2, the resulting answer, so the polynomial here has been, after evaluating at a particular point, you can see that we have resulted in having a single number. There are a couple of examples that we can also try for ourselves at home, as we call this class a beautiful day. Let's consider, these are take-home examples, let's consider a function, say f of y, where we have raised to the power 4, y raised to the power 4, plus 3y raised to the power 3, 3y raised to the power 3, minus 8y raised to the power 2, plus y minus 6. Let's consider this, and we should evaluate it at f equal to, evaluate at y equals 2, when y is 2. Now, lastly, let me consider another one, f of y, where we have 2y raised to the power 3, minus 5y raised to the power 2, minus 2y, plus 6, that we should also evaluate at y equals 4, at y equals 4. Now, all these I won't do because I know it's pretty simple. This is a polynomial expression, and you can see that it's of degree 4, though in a single polynomial of a single variable, and this also, the word for it is a quadratic expression, and then a quartic expression. Now, but we have been asked to evaluate this and this at when y is equal to 2. So yours is just to substitute. Whenever you see y, you just put the 2. Whereas in this other one, we are to substitute 4 whenever we see, and this is a cubic equation. Now with this that we have learned, I know we are good to go. From the beginning, we have been told that polynomials are algebraic expressions that consist of variables, numbers, and exponents, but they are not divided. Such expressions are not divided by a variable. They are not divided by a variable, and we have also been told that for it to be a polynomial, the power must not also be a fraction. It must not also be a fraction. So with this that we have learned, I know at least we are good to having a good knowledge of what a polynomial is. It's a quadratic expression. It's an algebraic expression that consists of variables, numbers, and exponents. Thank you, as we look forward to in our next class when we'll consider polynomial factorization. Thank you, and God bless you.